Right, imagine you built an AI agent, a proper useful one, and users love it. They're giving it their passwords, telling it exactly what to do, explicitly consenting to everything. And then a judge rules that none of that matters. That's what happened last week with Amazon versus Perplexity. And honestly, this changes everything for anyone building agents.
This is the Comet case.
Yes, so Perplexity built this shopping agent called Comet. It logs into Amazon on your behalf, finds products, makes purchases. Users wanted this. They gave it their credentials. They said yes to everything.
But the court said that's not enough.
Exactly. Judge Maxine Chesney ruled that user permission, even explicit informed consent, doesn't give an agent the right to access a platform. The platform has to say yes too.
It establishes what the ruling calls a trilateral framework. 3 parties: user, agent, platform. Each one can veto.
Right, but hang on. This wasn't just a technicality case, was it? Amazon warned them multiple times.
Oh, completely. Amazon sent 5 warnings starting back in November 2024. In August, they built a technical barrier specifically to block Comet.
And Perplexity updated the agent within 24 hours to circumvent it.
Oh man, yeah, that's not great.
No, so the ruling itself? Probably the right call given the facts. But the precedent is what matters here.
Because now every platform is a gatekeeper, legally backed.
Right. So if you're building an agent that touches any third-party service, user permission alone won't protect you. You need the platform's blessing.
Okay, but in practice, what does that actually mean? Like, if I'm building a tool that helps businesses manage their social media posts, do I need explicit permission from every platform now?
That's the question, isn't it? The ruling applied the Computer Fraud and Abuse Act, that's the statute used for actual hackers, to a commercial agent operating with user consent.
Which feels big.
Yeah, because suddenly the legal risk isn't just did the user want this, it's did the platform approve it.
And platforms can change their minds. They can block you tomorrow even if they tolerated you yesterday.
We've seen this pattern before, actually. Twitter's API changes in 2023, Reddit blocking third-party apps, same dynamic, platforms asserting control over their ecosystems.
But this makes it a legal framework, not just a business decision.
Exactly. And that's what makes this one different. So, what do you think? If you're building agents, how does this change your approach? Let us know in the comments.
Right, so moving on.
Okay, so this next one is properly clever, and it solves a problem I didn't even realize had a clean solution.
The personalization paper.
Yes, so how do you make a language model better at understanding individual users without collecting any new training data?
That sounds impossible.
Right? Because personalization usually means gathering more data, learning patterns, building profiles. This technique does none of that.
It's called MIPO, Mutual Information Preference Optimization. The approach is actually quite elegant.
Go on.
They generate pairs of responses. One answers the actual prompt correctly, the other answers a completely random, unrelated prompt. Then they teach the model to maximize conditional mutual information between prompts and responses.
Luma, in English.
Right, so basically, the model learns what makes a response relevant versus irrelevant. It gets better at being specific to the actual question being asked.
And that makes it more personalized?
Surprisingly, yes, because personalization is really about understanding context. What does this specific user care about in this specific situation? The model learns to be more contextually aware just by understanding relevance.
Okay, but does it actually work, like with real numbers?
3 to 40% improvements on personalization tasks using real user datasets.
That's not nothing.
And here's the bit that surprised me. The same technique also improved performance on maths problems and multiple choice questions by 1 to 18%.
Wait, it makes the model better at maths just by teaching it to be more relevant?
Apparently, it's a self-improvement framework, no human supervision needed.
That's interesting because it's not about adding capability, it's about focusing the capability you already have.
Which is way more practical than retraining from scratch.
And it scales. They tested it across different models, Llama Instruct variants, Quen models. It just works.
So if you're building something that needs to understand users better, this is worth looking at.
Yeah, because you're not changing your infrastructure, you're not collecting more data, you're just using what you have more intelligently.
Which honestly feels like the theme of everything today, smarter use of existing resources.
There's a pattern here.
There is, isn't there?
Right. So next one.
Okay, so this one's about money, and honestly, it's the gap nobody's talking about.
Oh, this is good.
So we've built agents that can write code, book meetings, spin up cloud resources, make purchases, basically act autonomously on our behalf.
And they're getting more capable every month.
Right, but there's a critical piece missing, money control.
Yeah, this is the one that keeps me up at night.
Think about it. You give an agent API access to your cloud provider. You tell it to spin up resources for a project. It optimizes for performance because that's what you asked for.
3 days later, you get a bill for £12,000.
Exactly, because it scaled up GPU instances and never scaled them down. The agent did exactly what you told it to do. It just had no concept of a budget.
This isn't theoretical. I've heard this story 3 times in the last month.
And it's not even the agent's fault, right? You said optimize for speed, fast models cost more, it's following instructions.
But it has no framework for evaluating cost versus benefit in financial terms.
Most agentic systems right now have no spending limits, no approval thresholds, no kill switches when costs spike.
Right, and I've actually seen this with a client. They were testing an agent that books meeting rooms. Simple enough, except it started booking premium conference rooms because they had better availability. Nobody told it there was a budget difference.
See, that's the thing. The agent makes decisions that are technically correct but financially catastrophic.
It's optimizing for capability without guardrails on expenditure.
So what's the answer? Do we just not give agents financial access?
That limits what they can do, though.
The answer is we need financial controls built into the agent framework, spending limits, budget awareness, cost versus benefit calculations.
Basically the same constraints a human would have.
Right, because we wouldn't hire someone and say, optimize this project, without also saying, here's the budget.
But most agent systems don't have that layer yet. They're optimizing for performance, accuracy, speed, not cost.
And until they do, you're taking a real risk giving them access to anything that costs money.
So, question for everyone listening. Would your business survive if an agent optimized for performance without checking the bill? Let us know in the comments. I'm genuinely curious how people are handling this.
It's going to become a bigger issue as agents get more autonomous.
Yeah, the capability is outpacing the safeguards.
Which brings us back to the theme, doesn't it? Autonomy without constraints is just risk with extra steps.
That's a good line.
I know, right? Okay, next one, and this is going to surprise you.
The Europe piece.
Yes, so there's an argument building that Europe might actually be better positioned than Silicon Valley to lead physical AI.
Okay, I wasn't expecting that.
Neither was I, but the structural advantages are real.
ETH Zurich spun out 46 startups in 2025, not software companies. Physical AI, robotics, automation, industrial systems.
That's a lot.
And it's not venture hype, it's deep robotics and engineering research turning into companies.
Europe has something Silicon Valley doesn't. Industrial testing grounds, manufacturing heritage, factories that are still the economic backbone.
Right. So when you're building a robot that needs to work in a real factory, you need an actual factory to test it in.
Exactly, and Europe has those, not as theoretical future possibilities, as reality.
The sectors where European startups are emerging tell the story. Industrial automation, agriculture, healthcare robotics. These aren't consumer novelties.
They're places where mistakes cost real money and safety actually matters.
And here's the bit I found interesting. Europe's regulatory frameworks, which everyone complains about, actually create an advantage.
How?
Because if you can build a medical robot that passes European approval, you've built something that actually works. Full stop.
The regulations force robustness from day one.
Whereas in the US, you might move fast and break things. But if you're building a robot that operates near humans in a factory, breaking things is not an option.
Right, and then there's spatial computing.
Europe's academic institutions have been leading spatial computing research for years. That expertise feeds directly into physical AI, robots that understand and navigate real-world environments.
So Silicon Valley has the capital and the cloud infrastructure, but Europe has the industrial partnerships, the testing environments, and the manufacturing knowledge.
Which you can't just acquire.
No, you need decades of industrial history to build those relationships, those supply chains, that institutional knowledge.
So physical AI isn't software, it lives in factories, hospitals, and fields, and Europe's structural advantages in those domains are real.
I'm actually genuinely optimistic about this.
Me too. It's nice to see a different angle on where innovation happens.
It also aligns with something we've covered before. Remember the farm robots episode?
The Living Lab one?
Yes, that was Europe too. Real farms, real mud, real testing conditions, not a lab demo.
That's the pattern, isn't it? Physical AI needs physical reality.
And Europe's got that in spades, right? Couple more quick ones before we wrap up.
The React component thing.
Yes, so this is a developer solution to a problem that every responsive layout has probably faced.
You've got a component that needs to live in different places depending on viewport size.
Right, like a coupon widget that's in the sidebar on desktop but in the middle of your content on mobile. Completely different places.
And the traditional approach is render 2 instances and hide one with CSS.
Which works, until someone rotates their phone. Then the state gets nuked.
This developer solved it using React portals combined with a media query hook. They built a wrapper that teleports a single component instance to different DOM locations while keeping its React tree intact.
So one instance, one state, one source of truth.
but displayed wherever the layout demands. It's one of those solutions that feels obvious once you see it.
But nobody talks about until someone actually builds it.
Yeah, this is useful. If you're working on responsive layouts with complex state, worth bookmarking.
Links in the description, and then there's the quantum one.
This one's properly clever.
Okay, so most quantum physics experiments focus on where interference fringes appear and how wide they are. Standard stuff.
But this research asks a different question. What if quantum probability itself, the Born rule, isn't quite right? What would that look like in an experiment?
Can you even test that? Isn't that just how quantum mechanics works?
That's what makes this interesting. The researchers showed that deviations from standard quantum probability would produce cubic skewness in interference fringe shapes.
Meaning?
The fringes would be asymmetric, but the positions wouldn't shift, the curvature wouldn't change, just the shape, skewed.
So you'd have something measurable.
Exactly, a falsifiable observable, not a philosophical argument, a measurement.
Do you think the Born rule is actually wrong?
Probably not. It's held up for a century, but asking the question properly matters. Because if there are deviations, this is how you'd find them.
Science advances by testing the foundations, not just building on top of them.
Exactly.
I like that. Even our most fundamental assumptions deserve good tests. And then, the last quick one, AWS enhanced their test state API for step functions.
Oh, this is going to make some developers very happy.
Right, so you can now test workflows locally, properly locally, with support for all the messy bits that used to require actual AWS infrastructure.
Map states, retry mechanisms with exponential backoff, wait for callback patterns, all of it.
Which means you can iterate on step functions workflows without deploying them.
Test edge cases, validate retry logic, debug callback timing, all before anything touches production.
Yeah, if you've ever tried to debug a step functions workflow in production, because that was the only place to properly test it, you know why this matters.
It's the difference between deploying 5 times to catch one bug versus catching it on your laptop.
Developer experience improvements like this are what make infrastructure actually usable.
Not flashy, just essential.
Right, so stepping back from all of that.
There's a thread running through everything today.
Which is?
We're in this moment where AI agents are capable enough to act autonomously, but the infrastructure around them, legal, financial, operational, is still catching up.
The perplexity ruling shows platforms asserting control.
The money control gap shows we're building capability faster than safeguards.
And the Europe argument shows that physical AI needs more than software expertise. It needs industrial reality.
Autonomy without constraints is just risk with extra steps.
That's the line. That's what ties everything together. Worth having a conversation about with your team this week. What constraints do your systems actually have? What assumptions are you making about permissions, costs, safety?
And whether those assumptions still hold when agents start acting more autonomously.
Because they will. The capability curve is steep.
Right, so that's it for today. Thanks for listening. Everything we talked about, links are in the description below. Full show notes over at luma.marbl.codes. And if you're enjoying these, hit subscribe so you don't miss the next one. Oh, and quick mention, if you're looking to hire AI talent or if you're an AI professional looking for your next role, check out Atlas AI Talent. We'll drop the link in the description. But yeah, thanks for listening. See you next time.